Hi guys, I'm back again with my lectures. This is Mr. Joseph, your chemistry teacher, and today's lecture is a continuation of our previous lecture on introduction to molecular and empirical formula. In our last lecture, we were able to state the relationship between empirical formula and molecular formula, and we were able to deduce the empirical formula. We are given the molecular formula, and I gave you a task to work on. I believe we must have done it, and I believe most of us got the right answer. But if you had made one or two mistakes, I'll be doing the correction today, and I want you to listen attentively so you can learn from your mistakes. But if you got the right answer, fantastic, perfect. I'm very, very happy. So let's take the correction. Limonene is a hydrocarbon found in the ring of citrus fruits. You are now asked, what is the molecular formula for limonene? They give you the structural formula of limonene. So let's go. Now, if you look at the structure, each of these points represents CH2. So this point is CH3. Here is CH2. Here is C. Here is C. And here is H. Here is CH2. Here is CH. Here is CH3. And yes. So all we have to do is to count the number of carbon and the number of hydrogen atoms. You can see it's a hydrocarbon, it contains carbon and hydrogen only. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? 10. We have 10 carbon atoms. So it is C10. Then we'll count the number of hydrogen. 3 plus 2, 5 plus 2, 7 plus 3, 10 plus 1, 11, 11 plus 2, 13, 13 plus 2, 15, 15 plus 4, 16. So 16 hydrogen atoms. So you can see that the molecular formula is C10, H16. So the answer to this is what? B. So you can see it's as simple as what? ABC. So you can deduce the molecular formula. We are giving the structural formula. It's just for you to identify each of the points and you get the right answer. So it's as simple as ABC. I believe most of us got their answer right, which is C. Fantastic. Thank you very much for that. If you made one or two mistakes, please, I want you to learn from your mistakes and solve as many questions as possible. It will be very, very clear. Thank you very much. So we are moving over to our next topic, which is calculation of empirical and molecular formula. So we'll start with calculation of empirical formula. Then move over to calculation of what? Molecular formula. Now, for you to calculate the empirical formula of an organic compound or any other compound, what you need the mass of each of the elements or the percentage composition by mass of each of the element. Now let's move on. So today we want to look at calculation of empirical formula. So to calculate the empirical formula of an organic compound or any other compound, whether organic or inorganic compound, to calculate the empirical formula, you need the mass of each of the elements that is present in the compound or the percentage composition by mass. So you'll be given the mass or you'll be given the percentage composition by mass, and you also need the relative atomic masses of each of the elements. So you need two major things. One, either the mass or the percentage composition by mass of each of the elements. Then you need the relative atomic masses of each of the element to calculate the empirical formula for any compound. So you'll be given either the mass or the percentage composite by mass, and also what? You'll be given the relative atomic masses of each of the elements, of which you can get that from your periodic table if you are not given. So now let's take an example. So this is a typical example. An organic compound X contains carbon, hydrogen, and oxygen only. Carbon X has the following percentage composition by mass. So here you are given the percentage composition by mass of carbon and hydrogen. You also calculate the empirical formula of compound X. But from the question, it contains carbon, hydrogen, and oxygen. And you are only given the percentage composition by mass of carbon and hydrogen only. So since it is in percentage, the total mass of what? Carbon, hydrogen, and oxygen is equal to what? 100. So let's move on. So it contains carbon, hydrogen, and what? Oxygen. So carbon is what? 54.55. Now hydrogen is 9.09. So to get oxygen, oxygen will now be what? 54.55 plus 9.09, then which will now be equal to use my calculator, 54.55 plus 9.09 is equal to 63.64. So since the total mass is in percentage, it will now be 100 minus 63.64, so that we can get the percentage composition by mass of oxygen, which will now be equal to 100 minus 63.64, it's equal to 36.36. 36.36. So that means carbon, okay, I think I need to erase this, 36.36. So that means carbon is 54.55, hydrogen is 99.09, and oxygen is 36.36. 54.55 is carbon plus hydrogen 9.09, oxygen is 36.36. So if you add up everything, it will give you to be equal to 100, just to prove that you are what? On track, you are correct. So having determined the percentage composite by masses of each of the elements, the next thing we need to do is what? To determine the number of moles. So divide both sides, divide through by the relative atomic masses of each of the elements. That is the reason you need the relative atomic mass. So carbon is 12, divide through by 12, which is the relative atomic mass of carbon, divide by 1, which is the relative atomic mass of hydrogen, you divide by 16, which is the relative atomic mass of oxygen. So it will now be 54.55 divided by 12. So you have 4.5. Then you have 9.09, which is 9 divided by 1. Then the next one is 36.36 divided by 16. Use your calculator. So you have 2.27. So the next thing to do is what? divide both sides by the smallest. So let me erase this. So you divide by the smallest, divide through by the smallest. So we have 4.5 moles of carbon, 9.09 moles of hydrogen, and 2.27 moles of oxygen. So divide through by the smallest, and the smallest here is 2.27. So you have 4.5 divided by 2.27, 9.09 divided by 2.27, then 2.27 divided by 2.27. So you raise this. .5 divided by 2.27. This 1.98, is approximately 2. And then 9.09 divided by 2.27, which is 4. 2.27 divided by 2.27 is 1. So we have the ratio of what? The ratio of carbon, hydrogen, and oxygen is 2:4:1. So the empirical formula of X is equal to what? C to H4O. So the empirical formula is equal to C to H4. So you can see it's as simple as ABC. Or you just need the percentage composition by mass of each of the elements, or the entire all the masses of each of the elements and the relative atomic mass. You can calculate the empirical formula of any given compound. It can be an organic compound, it might be an inorganic compound. You can solve as many questions as possible. Yeah, thank you very much. So you can see that it's very, very simple. And feel free to reach out to me for any difficulty. Let's take another example. I'm going to erase this. So this is another example. When 127 grams of copper combined with oxygen, 143 grams of an oxide are formed. Oxides are compounds that are formed when an element combined with what? Oxygen. So oxides are compounds of an element with oxygen. So they say, what is the empirical formula of the oxide? So the first thing we need to do is that the oxide, copper, contain what? 127 grams. Then the oxide is equal to what? 143, which is copper plus oxygen is equal to 143 grams. So if copper is 127, so oxygen will now be equal to what? 143 minus 127. So I'm going to use my calculator here. 143 minus 127 is equal to what? 16. Very good. So we now have copper as 127. There's the mass of copper. The mass of oxygen is what? 16. So the next thing to do is to divide both sides by the relative atomic mass of each of the elements. So the relative atomic mass of copper is 63.5. So we divided by 63.5. Relative atomic mass of oxygen is 16, so divided by 16. So 127 divided by 63.5. This one is 2 and this is 1. Therefore, as simple as ABC, the empirical formula of the oxide will be equal to what? Cu2, which is 2:1. So 2 atoms of copper and 1 atom of what? Oxygen. As you can see, it's as simple as what? ABC. All you just need to do is to attempt as many questions as possible and reach out to me for any difficulty, any challenge. Now, we're going to solve one more question before the end of today's class. The percentage by mass composition of X, the percentage by mass composition of X is C is 54.5, which is carbon, hydrogen is 9.10%, and oxygen is 36.4%. Find the empirical formulas of X. It's as simple as ABC. The compound contains carbon, hydrogen, and oxygen, and you are given the percentage composition by mass of carbon, hydrogen, and oxygen. So let's take this. Carbon is 54.5, hydrogen 9.10, oxygen 86.4. So these are the percentage composition by mass. So you're asked to calculate what the empirical formula is. So divide both sides by the relative atomic masses of each of the elements. Carbon is 12, carbon is 12, divided by 12. Hydrogen is 1, and oxygen is 16. So 4 and 5 divided by 12. So here you have 4.5. You have 9.10. Then 36.4 divided by 16. So we have 2.27. So divide both sides by 2.27. Divide both sides by 2.27. Divide both sides by 2.27, which is the smallest. So express it in the simplest ratio. So 4.5 divided by 2.27. So this one is approximately 2. This one 9.10 divided by 2.27. This is approximately 4. This is 1. So the empirical formula of X is equal to what? C2H4. So this is the empirical formula. So it's as simple as ABC. So I expect you to solve as many questions as possible before our next class. If you experience any difficulty, any challenge, please feel free to reach out to me. I'll always be there for you. I'm always available for you. I'm Mr. Joseph, your chemistry teacher. Please subscribe to my YouTube channel, comment, and reach out to me for any challenge, for any difficulty. I'll always be there for you. Thank you very much. But before I leave, I will give you a task to work on. So let's take it. So these are the tasks that I'll be giving to you for today's class. So please, I want you to attempt these questions and also attempt other questions. By our next class, I'll take the correction. You're going to learn from your mistakes, if at all you have made any mistake. But I strongly believe that you're able to solve these two questions. So please solve as many questions as possible for perfection. and also solve these two questions I've given to you. So we'll meet in our next class. Once again, I'm Mr. Joseph, your chemistry teacher. Free to reach out to me for any difficulty. I'm always there for you. Thank you very much.